Hey Ninja Warriors, today's session is going to be about probability, wherein we are going to study all the theory, or you can say concepts from the chapter probability, and also we are going to talk about previous year questions which were asked in your CBSE board examination, be it your MCQs, be it your 2-marker question, or even 4 or 5-marker question. Okay, so over here you can see the weightage. Now let me just burst this myth. Calculus is obviously one of the high weightage unit, but when it comes to a chapter which is a high weighted chapter and which is giving you high return on investment, that is clearly going to be probability, ma'am. Why? But because calculus unit is 35 marks, you are seeing only 8 marks. How come? Because 35 marks is not for one chapter, but it is for 5 chapters. So if you carefully observe, I can see continuity and differentiability is sitting at 9 marks, but again 2 chapters. Okay, then integrals 9 marks. So integration and differentiation, very big chapter. Okay, differential equation 7 marks. Now this is the actual high weighted chapter you should focus on. In calculus, if you want to focus on any chapter, that has to be differential equation. But again, for differential equation, your differentiation and integration should be sorted. So that is one thing. Then we have vector algebra. I think this is the most real high weighted chapter, because again, no prerequisite are required in vector algebra. Then we have probability. Okay, so this is again the second best chapter which you should focus on. So top 2 chapters if you want to focus on is probability and you can say vector algebra. Okay, because no prerequisite are required, number 1 point, and high weightage is there. Okay, just 2 chapters and 9 plus 8, you can see 17 marks in your pocket. In this session, obviously we are going to cover theory part. Okay, all the formulas, all the concepts, all the theory, and we are going to cover PYQs, and also we are going to understand how to write any question. Okay, how to present any question in such a way that even if you do not know the answer correctly, even if you feel, okay ma'am, I just do not know this 3-marker question ka answer correctly, but the way you write it, that can also fetch you 2.5 marks. So that is very important. You have to be very smart in another way when it comes to CBSE boards. Okay, now probability basic definition, if you can see, probability is something like how likely something is to happen. Okay, so E be an event in a sample space. So first of all, there is a sample space. First of all, okay, forget about anything. Let me start with random experiment. Random experiment. Now what is a random experiment? Random experiment is that experiment wherein outcomes are known to you. For example, throwing a dice. Oh, obviously outcomes are known to you, ma'am, because it can either get you 1 or 2 or 3 or 4 or 5 or 6. Okay, you can't get elephant if you roll a dice. Okay, so random experiment, although the name is random, but it is actually very predictable that what all outcomes can come. So now sample space is that term which will consist of all possible outcomes. Okay, and there will be an event E or A or B, whatever. Okay, so there will be an event E which will be subset of sample space. That means that will pick only few, I would say that will pick only few elements of sample space. Suppose your sample space in throwing of a die is 1, 2, 3, 4, 5, 6. Correct? Right or wrong? Yes. Now this is your sample space and E be the event. So your event is 2, 4 and 6. Okay, so getting an even number is an event, which is a subset of a sample space. Okay, so now probability will be what? Number of favorable outcomes upon total number of outcomes. So probability of getting an even number in this example will be what? Total number of favorable outcomes will be 3 and this is 6. 3 by 6 will be 1 by 2. Probability is what? Favorable outcomes number and total outcomes number. Now understand, this is one very important thing, that probability can either be 0 or be 1, and probability can be in between 0 and 1. Probability cannot be 3 by 2. 1.5 cannot be the probability. Probability can be 0, can be 1, and probability can be between 0 and 1. This is the range of the probability. Now, this is very easy and very popular formula which is probability of A union B is equals to probability of A plus probability of B minus probability of A intersection B, correct? Now, probability of A bar, that is A complement. So, suppose now just tell me probability of A, which is getting an even number, was 3 by 6, correct? 1 by 2. Now, can you tell me probability of not getting an even number, that is A bar or A complement? That is going to be 1 minus probability of getting an even number. So, basically your answer will be 1 minus half 1 by 2. So, probability of A complement or probability of not A is 1 minus probability of A. Okay, ma'am, clear? Now, these are some important definitions which you all should know. First of all, random experiment, I already told you. Outcome. Outcome of a random experiment. So what is this term outcome? That means what all you can get from that random experiment. Sample space, I already told you, all the total possible outcomes will be written down in sample space. Then event. Event will be something very specific. Suppose getting an even number, getting an odd number, getting a 1, getting a 3, getting a 7. Okay, so this is your event. Impossible event. Now I told you, getting a 7 on a throw of dice. So you'll be like, ma'am, what? Yes, it is an impossible event. Probability of getting a 7 will be 0 because it is an impossible event. Probability of getting a number which is either 1 or 2 or 3 or 4 or 5 or 6. Or you can say probability of getting a number which is either even or odd. So you'll be like, this is what we are going to expect, right? This is so surely going to happen. If you throw dice, either it will be even or it will be odd. So sure event is something which you definitely are going to get. So probability of that sure event will be 1. Okay. Remember, impossible is 0, sure is 1. Now some very, very important definitions. Mutually exhaustive event. Okay. Very, very important. Suppose again, let's take example of dice. Sample space 1, 2, 3, 4, 5, 6. Okay. Now there is an A event which is getting an even number. There is another event getting an odd number. Okay. So now even number and odd number are disjoint event. That means A intersection B should be null. Okay. So two events A and B are mutually exclusive if occurrence of any one of them excludes the occurrence of other. Okay, so basically disjoint set. So if Venn diagram how do you represent mutually exclusive? Like this. Okay. Now exhaustive event. Understand what is exhaustive event? Suppose you are having event A and this is event B. By the way, you usually see that, ma'am, the event is represented by, this is A, this is B. Event is represented by circle, but it is not the case. It can be represented by any shape. So this time 2 rectangles you can see. This is completely sample space. This is A, this is B. Okay, and this rectangle is S. Now tell me A union B. If you combine A union B, you are going to get what? Complete sample space, which is the case with this example as well. Just tell me what is A union B. If you combine A and B, you'll be like, okay ma'am, A union B is 1, 2, 3, 4, 5, 6, which is nothing but a sample space. So exhaustive events will be in such a way, if you take union, you will directly get all possible outcomes. That is, you're going to get sample space. These are the important definitions you should understand. Now, let us quickly start with some basic definitions. I think we have cleared it out. But in mathematics, no amount of theory can help. You also know this, right? You have to practice, you have to solve variety of problems. That is why theory is there, but in between you have to pick the pen, lift the pen and literally solve it. Because if you're going to binge watch me, it is going to help, but not in that. Just pick the pen and solve it with me. What are you doing, okay? A family has 2 children and the elder child is girl, okay? 2 children, so elder and younger, and they are telling that elder child is girl. Okay, now the probability that both children are girls. Now what can happen? What are the possible outcomes? Okay, so possible outcomes will be what? Elder child will be girl. and the elder child is girl. Okay, so this is elder and younger. It could be girl, girl. This is the favorable outcome. This is girl and this is boy. Boy, girl, and boy, boy. These are the four possible things that a family has two children and elder child is girl. Okay. Hold on. I have a doubt in this. And the elder. No, it's correct only. So yes, I was just checking the validity of the question. Sometimes they say at least also, but this is the correct one. Now just tell me what is the sample space. Ma'am, sample space is 4. Now both childs are girls. So favorable outcome means what? Both child being girls. So both child being girls is number of favorable outcomes or event A. This is 1. So your probability will be NA upon cardinality of S, which is 1 by 4. Clearly, option A will be absolutely correct. Okay. All right. So this is what it is. And so this is how you need to write. Okay. Or either it is better if you just write the sample space. Girl, girl, boy, girl, girl, boy, boy, boy. Sample space is 4. Now both being girl, event E. So cardinality of event E is 1. 1 by 4. If you write in this manner, although this was a MCQ, but again, this is how you write. Now, another question on your screen. Hold on. Hello. Hello. Yes. 5 coins are tossed simultaneously. Find the probability of event that at least one head turns up. One head turns up. Okay, 5 coins are simultaneously tossed. Now just tell me one thing, that 5 positions are there. Okay, 1, 2, 3, 4, 5 and yes, 4, 5. Just tell me that 2 raised to power 5, there will be number of total outcomes will be 2 raised to power 5. Okay, that is 32. In which, understand that 31 outcomes will be those outcomes which will have at least one head. Obviously, there will be just one outcome which will be all T, no head. So there is just one outcome which will have all T. That means no H. So what does that mean? Probability is going to be, just tell me that at least one head will be there in 31 outcomes. So event A, cardinality of event A, which is getting at least one head, is 31. So your answer will be 31 upon 32. This is the probability. That's how you write. Total number of cases 32. One of the cases will be all 3 tails, all 5 tails, correct? So remaining 31 cases are valid. Probability event getting at least one head is 31 by 32. Now this is something which is very, very important, that is conditional probability. Okay, conditional probability says that probability of one event given that the other event has already occurred. Let me tell you, A and B are two events associated with same sample space of a random experiment. The conditional probability of event A, now understand this, event A given that B has already occurred. Event probability of, now let me just repeat it, probability of event A given that B has already occurred. So the way of writing in mathematical form is probability of A given that B has already occurred. This is how you write. Okay. So the formula will be, so probability of A given that B has already occurred will be probability of A intersection B upon probability of B. Now you will be like, ma'am, direct formula you are telling. But if you try to understand with the help of Venn diagram, then also you will understand. Probability of A you are looking for, but specifically that region where B has already occurred. Okay. So probability of A, so this is your A, this is your B. Just tell me where exactly B has occurred. Ma'am, in this circle B has occurred. Now in this circle, can you just tell me, can you point out where is A? Because A when B has occurred. So B has occurred is this. Now where is A? This is the only portion which is A, where B is occurring. So this is probability of A intersection B upon, now B has occurred. So total number of outcomes will be probability of B. So this is the formula which you all should remember. Probability of A given that B has already occurred. Okay. Now, very, very important properties that you all should know about conditional probability is probability of not having, probability of not A given that F has already occurred is 1 minus probability of E given that F has already occurred. Okay, so this is what a formula which you all should remember. Do not worry, because we are going to do some questions based on this. CBSE 2024 MCQ. Your Ninja ma'am is bringing latest questions in front of you. Are you getting this point straight in your head? Probability of A given that B has already occurred is probability of A bar. Oh, so we to know the formula, ma'am. You just told us that probability of A given that B has already occurred is 1 minus probability of A given that B has already occurred. Now, so this is, ma'am, twice probability of A given that B has already occurred is equals to 1. Twice probability of A given that B has already occurred. Understand? Probability of A intersection B upon probability of B is equals to 1. Direct formula. Remember the formula, conditional probability formula, right? So probability of A intersection B, and can you see, is equals to 1 by 2 probability of B. Okay. All right. Perfect. So which answer is correct? Tell me. Option C is absolutely correct. Okay, ma'am. Perfect. Now, shall we move on to the next problem? Yes. A card is picked at random from a pack of 52 playing cards. Okay. Given that picked card is a queen. Okay, given that. Probability of this card to be card of spade. So basically what they are asking is probability, understand, probability of card being spade given that it is a queen, card is a queen. Okay, so first of all, this we have made it very sure. Now spade, tell me that what is, do you know what are the detailing of the cards? 52 cards wherein 13 spade will be there. Okay, then 13 clubs will be there, 13 diamonds and 13 hearts. Okay, now there will be one queen over here one queen over here, one queen over here, one queen over here. Okay. So now understand. This is probability of card being spade. Intersection, it is a queen. Formula. Intersection upon probability of card is a queen. Okay. So probability of card being spade, give an intersection queen. There is one queen in spade. One queen in spade. So probability will be 1 upon 52. Whole upon card is queen. How many queens in total in general do you have? 4 by 52. So your answer will be 1 by 4 in this case, in this scenario. And now how do you write it? Same. I told you. A be the event, card is queen. B the event, card is spade. You want probability of card is spade given that card is queen. So B slash A. B intersection A upon PA, and this is how you have got. In case of any doubts, just comment the timestamp now. I'll be replying it to you. Next question on your screen without any further delay. Now I think this you can actually do it. A and B are two events such that probability of A is given. First of all, now, if you do not know anything, now just note down everything. Probability of B is given as 1 by 2. Some misprint is there. Then probability of A given that B has already occurred is 3 by 4. Then what they are asking is probability of B given that A has already occurred. Okay. So one by one we will tackle. So first of all, I am going to attack this information, which is probability of A given that B has already occurred. I know this formula, which is probability of A intersection B upon probability of B. Okay. So this is A intersection B, but ma'am, A intersection B, so we do not know. Okay. So what? That is what you have to calculate. A slash B is 3 by 4, put the value. Probability of B is 1 by 2, put the value, and intersection is right here. So this is 3 by 4 into 1 by 2 is equals to probability of A intersection B. This is 3 upon 8. Probability of A intersection B. This is what you have got. Okay. Now, probability of B slash A. What is the formula? Probability of B given that A has already occurred. So probability of A intersection B upon probability of A. Intersection is 3 by 8. Probability of 8 is already given 5 by 8. So final answer will be 3 by 8. This is the correct answer. Have a look. Let me know. Okay. You can pause and check. Now the next question, CBSE 2019 question, probability not A is 0.7, probability B is 0.7 and probability of B slash A is 0.5. Find probability of A slash B, okay. So probability of A bar is 0.7, probability of B is also 0.7 and now probability of B given that A has already occurred is probability of A intersection B upon probability of A. So this is 0.5. Plug in the values. Probability of A intersection B is something which we don't know. Probability of A also we do not know, but we can calculate because probability of A is going to become 1 minus probability of PA bar. 1 minus 0.7 is going to be 0.3. So this probability of A is going to be 0.3. Understanding? Okay. So now this is 0.15 is equals to probability of A intersection B. That's what you've got. Okay, ma'am. Now, what you have to do is probability of A given that B has already occurred. Now, so you must be knowing this formula. If A is in the denominator, A will be in the denominator. Now, B is in the denominator. So, B will be in the denominator. So, probability of B will be 0.7. A intersection B will be 0.15. Okay, so this is actually 15 upon 70. If you reduce it, 5 3s are 15. 5 1s are 5. 5 4s are 20. So 3 by 14. 3 by 14. Yes, 3 by 14 is the correct answer. That's it. Okay. So probability is 3 by 14. That's it. You have to write. Correct? Clear? All good? All clear? Shall I move on to the next problem now? Before next problem, we need something to study very urgent, and multiplication theorem is the topic. Now, I'll make your life very, very easy. Multiplication theorem is nothing but the same thing, conditional probability. Tell me, what was conditional probability, ma'am? Conditional probability is probability of B, given that A has already occurred, is probability of A intersection B upon probability of A. That's it, okay? Multiplication theorem suggests that you just multiply this denominator to the left hand side so that you get PA intersection B is probability of A multiply probability of B intersection A. So this is a multiplication theorem, but how to apply it, that is something which is very, very important, okay? How to apply it. So let us just do some couple of problems on multiplication theorem to get hang of it. Two cards are drawn at random one by one without replacement from a well shuffled pack of 52 playing cards without replacement, okay? Find the probability that one is red and other is black. Very easy, okay? One is red and other is black. So what to do? See, because we are doing one card and then two cards, so there will be first card and second card, okay? So now just tell me, probability will be probability of first card being red, second will be black, plus probability of first card being black, second will be red, okay? This is how the total probability works. Now first card being red, you know 52 cards are there, 26 black, 26 red. So 26 upon 52. Now that you have removed one red card, still 26 black cards are intact. So this is 26, but total cards are 51 plus. Same, if you pick a black card, now you have again 52 card intact, 26 black. So this is how it is, and 26 red, but now total will be this. If you solve it, you are going to get 1 by 2. So 1 by 2 into 26 by 51 plus again 1 by 2 into 26 by 51. If you solve it, 26 by 51 will be the final probability. Okay? Alright. Now, ma'am, how to write properly? Show us this. Probability, see on the screen, probability that one card is red and other card is black is equals to probability of first being red, second is black. Probability of first is black and second is red. Now see, same calculation without replacement obviously you are doing. So now calculation you do on your own and then step by step you write the correct answer, okay? Now, alright. Perfect. Now again another question, CBSE 2020, sometimes in probability they give you some difficult, like some questions which are not difficult, but sometimes questions might be annoying. The probability of finding green signal on a busy crossing X is 30%. That means 30 by 100, 3 by 10. So probability of getting green signal on X crossing is 30 by 100 or 3 by 10. So probability of not seeing a green signal will be 7 by 10. Okay. What is the probability of finding a green signal on 2 consecutive days out of 3? Okay. So 2 consecutive days out of 3. So probability will be what? Now 2 consecutive days, day 1, day 2. So you get day 1, day 2, but not on day 3. Plus probability is D1 pay you will not get, but D2, D3 you can get. Only 2 options. You can't be having D1, D3 as the option. Now probability of getting a green signal is 3 by 10. Probability of not getting green signal is what? 7 by 10. So now D1 pe you are getting green signal, ma'am, 3 by 10. D2 pe again green signal, but D3 pe you are not getting green signal, plus same. Not getting green signal, getting green signal, getting green signal. So this is your 7 threes are 21, 21 into 3, 63 by 1000, or 0.063 is your final probability. Now how to write? See, probability of green signal is 3 by 10, not green signal is 7 by 10. Probability of getting green signal or 2 consecutive days will be day 1, day 2 green, day 2 not green. Then day 1 not green, day 2, day 3 green. So 63 by, sorry, this is 2 multiply, correct? So now this is 63 by 500, okay? Calculation mistake. Because 7 into 3 into 3 into 2, because you have to add also, no? So 63 by 500 will be the answer, okay? All right, clear. Now we are having independent events, okay? Independent events. This is very important. Independent events. See, I am telling you the dependency in my house, first of all. Suppose my mom and dad are fighting. They had a fight. Cold War, just like any other couple. Now, just tell me that my mom, dad fighting and I will get the food today. Are these two independent events? Think about it. I to feel these are dependent event. Although in the world of probability, they might say, what is the correlation? But a traumatized kid like me knows the value of, if they are fighting, then I will not get food. Who will prepare then? Okay. So just on a lighter note, independent events. Now understand. Independent events are not just disjoint events. Disjoint event is completely different. Independent events can have their intersection, but it's just that one event occurrence, they can simultaneously happen. They can simultaneously happen, but occurrence of one event does not depend on occurrence of second event. Okay. Suppose I am taking a trip to Goa and Diksha ma'am is taking a trip to Kashmir on a same day. Okay, so these are independent events, although they are occurring at the same time. So if they are doing it the same day, we are going to fall in this category. But if we are planning that, okay, you go on day 1, I'll go on other day, so that is this and this. Okay, but events are independent. Her planning is not dependent upon me. So this is how the events will be independent event. Okay, now very important, if two events are independent, then their intersection, probability of intersection of two events will be product of their probability is very important independent event. So now just tell me one thing, probability of E given that F has already occurred is what? Probability of E intersection F upon probability of F. You all know this? Yes ma'am, definitely. This is very important. Now just tell me one thing, that because now if I tell you, what if I tell you E and F are independent events? So you'll be like, okay, then probability of E, probability of F upon probability of F. Okay, so ye cancel. So probability of E given that F has already occurred is nothing but probability of E. And if you apply your common sense, now that is true. Probability of me going to Goa given that Diksha ma'am has gone to Kashmir is probability of just me going to Goa, because how does it matter if Diksha ma'am is going to Kashmir or not? Are you getting my point? So probability of A given that B has already occurred, if A and B are independent events. So B has occurred or B does not has occurred. It doesn't matter to A will happen. So probability of A given that B has already occurred, A will say that I am not interested in you. B, you happen, you do not happen, just go away. So this is probability of directly. Just remove the denominator part if both the events are independent. This is helpful for your competitive as well. Okay, now two events are independent if intersection is equals to product of their probability. Two events are dependent if this is not equal, obviously vice versa. Now three events, if at all they are independent, mutually independent, A, B, C are said to be mutually independent. If pair wise, so A, B, A, C, B, C should be independent, and now A, B, C should also be independent. So this is, it should actually satisfy all four conditions. Okay, so now again, some people might still have difficulty in disjoint sets, okay, and mutually disjoint sets and independent event. Okay, so I told you that disjoint may intersection is null, independent may intersection cannot be null. Okay, so disjoint, that means mutually exclusive, we studied this. PA intersection B will be 0, null, but here PA intersection B will be probability of A into probability of B, and this is the Venn diagram variation of the two. Now let us talk about this. Okay, let us talk about this. CBSE 2024 problem. A and F are two independent events such that probability of E complement is 0.6. So from here we can write probability of E is 0.4. Probability of E union F is 0.6. Okay. Find probability of F. Okay. So yes, we are going to apply the basic formula probability of A union B. Sorry, not A. E. E union F is equals to probability of E plus probability of F plus minus probability of E intersection F. Now understand, E and F are independent. E union F, start plugging in values. 0.6, probability of E is 0.4 plus probability of F, and this is probability of E into probability of F. So 0.4 multiply probability of F. Okay. So this is 0.2, just the calculation, PF minus 0.4 PF, 0.6 P of F, and this is 1 by 3 is going to be probability of F. Okay, all right, clear? CBSE 2024. So 1 by 3. Now they are asking you probability of E complement union F complement. Probability of E complement union F complement. So just understand, probability of E bar union F bar is nothing but 1 minus probability of E intersection F. Do you remember this formula? Okay. Probability of either not E or not or is this. So 1 minus E intersection F, so 0.4 into 1 by 3. So 0.4 by 3. This is going to give you 1 minus 2 by 15, 13 by 15. Okay, so this is probability of E complement and F complement. Okay. All right. CBSE 2023 problem, a similar type of problem. A and B again are independent events. By the way, one very important information I would like to give you. If A and B are independent, okay, this you can get this question that prove this. Okay, so this you have to be proved. If A and B are independent, then A bar and B, A and B bar, all possible combination, A bar and B bar, all three will be independent only. You can use this and you can write, if A and B are independent, then A B bar, A bar B, A bar B bar, independent only. Okay. So now A and B are independent such that A intersection B bar is 1 by 4. So what you can do is, A intersection B bar is probability of A, probability of B bar, they are giving 1 by 4. So from here probability of A, 1 minus probability of B is 1 by 4. Second thing, probability of A bar intersection B. Probability of A bar intersection B. So probability of A bar, probability of B is 1 by 6. Now this, 1 minus probability of A and probability of B is equals to 1 by 6. Correct? So probability of A minus probability of A, probability of B is 1 by 4. This is first equation. This is probability of B minus probability of A, probability of B is equals to what? 1 by 6. Now what to do? Now what to do? Basically 2 equations, 2 unknown. Correct or not? See, probability of A minus, probability of A, let us assume as A minus AB is 1 by 4. B minus AB is 1 by 6. Okay. So now what you can do is calculate the value of A from here, which is equals to 1 by 4, 1 minus B. Plug in over here. So B minus 1 upon 4, 1 minus B is equals to 1 by 6. Now this is a good question. Quadratic in B you will be getting formed. 4B minus B square. 4B minus 4B square minus 1 is equals to, and this is 6 also, okay, is equals to 4 minus 4B, correct? 6 4s are 24. 24B minus 24B square minus 6 is equals to 4 minus 4B, okay? All right. Now 24B square. This is minus 24B, so minus 28B. Correct? This is gone. This is also gone. And this is plus 10 equals to 0. So 12B square minus 14B plus 5 equals to 0. 12 5s are 60. 60. Minus 13x plus 3 hai. Something is not right, I feel. Okay, let me just check. Hold on, let me just start it from here. A minus AB is equals to 1 by 4. Okay. B minus AB is equals to 1 by 6. Correct? Okay. Now, let me do one thing now. Let me subtract these two. So, A minus B will be equals to 1 by 12. Correct? Now, from, subtract these two equations. Now, from here, A 1 minus, yes, A value, you can put it over here. 1 by 4, 1 minus B. Minus B is equals to 1 by 12. Okay? Take LCM. So, if you take LCM, 4, 1 minus B, this is 1 minus 4B, 1 minus B is equals to 1 by 12. 4 1s are 4 3s are. 3 minus 12B plus 12B square is equals to 1 minus B. Okay. So, now this is 12B square and this is your minus 13B plus 2. 3 and okay 1 plus 2 equals to 0 plus 1, it should be plus 1 not 2. So 3, your equation should be like this, right? Plus 3, it should be plus 3. 1, 3. Hold on, no, let me check. Okay, let's see. So 12 and 2, 24. 24, so 8 3s are 24, right? Then 6 4s are 24. No, it is not actually happening. Have I done any mistake? 3 minus 4 3s are 12. And this is what? 1 minus B. So, oops. ये जाके 11 हो जाएगा ना ये. Hold on. This is going to become 11. Okay. Yes. 12 and 2. 24. 24. So 8 3s are 24. Yes. 12B square minus. Now it's fine. 8B minus 3B plus 2 is equals to 0. So this is your, if you take common 4b, 3b minus 2 minus 1, 3b minus 2 is equals to 0. So b is 2 by 3 comma 1 by 4. 2 by 3 comma 1 by 4. So b is 2 by 3 comma 1 by 4. So just plug in the value of a and b, you will get the answer. But in here they are saying something else. So I think this calculation is fine, because see, the solution is different. X minus y is equals to 1 by 12. When I am doing, I am getting this 36 ka 9 4 हाँ ठीक है. I think B is 2 by 3, correct. So yes, we are actually correct. So now understand, if your B is 2 by 3, then your, that means probability of B, that means your A will be, you put the value 3 by 4. You put the value in this. Okay. If your B is 2 by 3, sorry, if 2 by 3 is done now. If your B is 1 by 4, then your A will be what? Tell me. A will be 1 by 3. So this is two sets of probability of A and B you are getting. This is a good question, I would say. A and B are independent events such that this, find PA and PB. So this is how it is done. Okay, so this like question, if you create a quadratic in A, the quadratic will be different. If you create a quadratic in B, quadratic will be different. Both are correct. Both are going to give you the same answer. Okay, all right. Now CBSE 2021 question. Events A and B are such that probability of A is given, B is given, and this is also given. Probability of A bar union B bar. Tell me, probability of A bar union B bar is what? Ma'am, 1 minus probability of A intersection B. So now this is 1 by 4 is equals to 1 minus probability of A intersection B. So probability of A intersection B, from here you're getting 3 by 4. Now you have to verify that whether they are independent or not. So probability of A intersection B should be equals to probability of A into probability of B if the events are independent. So if they are equal, then independent, otherwise not. A intersection B is 3 by 4. Yes, ma'am. Probability of A is half. This is 7 by 12. I don't think so. It looks like that they are equal. So not independent events. They are not independent events. Not independent events. CBSE 2022 question. Now we are having a total probability theorem, which theory though I am going to skip it right away. I'm not going to teach you theory part. Okay. So ma'am, what then what? Direct question say I'm going to explain you, because understanding theory will fry your brain. Okay. Bag A contains 3 white and 2 black balls. Bag B contains 2 white and 5 black balls. One of the bag is chosen at random and a ball is drawn from it. What is the probability that ball is white? So basically you want the probability of ball being white. Now total probability theorem. How can you get ball white? You can get ball white from bag 1 or bag 2. So just probability of getting white ball from bag A plus probability of getting white ball from bag B. Okay, so for that you have to select, okay, the bag 1. So probability of, how do you write? So probability of, now just understand. How do you write? So first of all, E1 will be choosing bag A. E2 will be choosing bag B. Okay. So this is probability of choosing bag B, bag A, and probability of getting a white ball given that it is coming from bag A, plus probability of E2 and probability of getting white ball from bag number. This is how you write. This is the total probability. So probability of E1 is half. Probability of getting white ball from E1 bag is 3 by 5. Plus again half. and now this time 2 by 7. So this is how it is. This is 3 by 10 plus this is 2 by 7. 70, 21 plus 20, 41. This is your final probability. Now let me tell you how do you write it. 31 by 70, okay. Now how do you write it? E1 is event that bag A is chosen, E2 is bag B is chosen, okay. Event A's white ball is drawn. The probability of bag 1, choosing bag 1 is half and bag 2 is also half. Probability of A given that, probability of white ball given that it is from bag A, probability of white ball given that it is from bag B. This is what is written, okay. So yes, this probability is 3 by 5, this is 2 by 7. Now 1 by 2, 3 by 5, 1 by 2, 2 by 7. Just multiply it, 31 by 70. This is the total probability theorem, okay. How much, basically, in how many ways you can get white balls, so you have to add all the probability. This is how you have to write. And now is the time for your very own Bayes theorem, and we are going to do, okay, a couple of questions on Bayes theorem, okay. All right, Bayes theorem. Again, if I get into the theory part, you'll be like, ma'am, so many formulas, so many things. Directly, I am going to tell you that how to solve a question using Bayes theorem, and then you at the end beautify it, okay. If you start thinking in beautification, that means presentation in the beginning, you might lose the question crux. So let's just solve that question, because see, Bayes theorem mein the final step is one step only. Then the writing part will take majority of the time. So understand what does Bayes theorem require. I'll show you right away. Bag contains 4 red and 4 black balls. Oops. 4 red and 4 black balls. Another bag contains 2 red and 6 black balls. One of the 2 bags is selected at random and a ball is drawn from the bag which is found to be red. Find the probability that the ball is drawn from the first bag, okay. First of all, how do you identify this is a Bayes theorem? Bag is there, denotion of bag is there, another bag is there, also there. One of the 2 bags is selected and random, a ball is drawn and found to be red. This indicates something they have done, and in the past they are claiming that this is fixed. Ball is red. Find the probability that it is coming from bag number 1. So now, let me just write. So in the denominator, we are going to write total probability. Remember, we did total probability theorem. So in the denominator, we are going to write exactly like this. So probability of E1, probability of getting, okay, probability of selecting a bag, multiply probability of ball is from bag number 1, given that it is a red colored ball, plus, okay, probability of selecting a bag, given that probability of it is coming from E2, given that it is a red color ball. Now first bag, this is the denominator, right? Numerator will have obviously favorable outcome. So first bag is what they are asking. So probability of E1, given that E1 slash R, okay, E1 slash R. Now probability of E1 will be half because 2 bags are there. Now probability of ball, red ball coming from E1 bag, red ball coming from E1 bag, okay. Let me check one time. Sorry, this is a reverse thing. This is not how you write. Yes. Probability of E1 slash R, correct? This is E1 slash R. This is also probability of E2 slash R. Yes. So probability of bag multiply probability of red ball coming from E1. So 4 by 8. Okay, ma'am. Upon this is again 1 by 2 into 4 by 8. Plus 1 by 2 into second bag, 2 red and 6 black, 2 by 8. Correct? So this is going to give you half, half, half to cancel. 4 by 4 plus 6. So this is 4 by 10. 0.4 is the probability. How do you write? Okay, how do you write? Now the beautification will come into the picture. Now the beautification will come into the picture. Okay. So first of all, E1 be the event of choosing bag 1, E2 be the event choosing bag 2. Okay, A is the event of drawing a red ball. You can mark it as R as well. Probability of E1 and E2 both are half. Probability of red ball coming from E1 is what? 4 by 8. Probability of red ball coming from E2 is 2 by 8. And Bayes' theorem says that in the denominator, what do you want? Probability of selecting bag 1 given that ball is red. It is already given, right? Is nothing but probability E1 A slash E1, probability of E1 A slash E1, probability of E2 A slash E2. Same thing you have to perform. This is what your Bayes theorem looks like. Okay. All right. Clear? Now, another question. Another question from Bayes theorem, correct? A card from a pack of 52 playing cards is lost. Okay. CBSE 2024, very good question, very popular question. 4 times, 5 times you should do it. Okay. Learn how to practice it and present it. From the remaining cards, a card is drawn at random and found to be king. Can you see Bayes theorem? Spotted. Something is found to be that. Okay. Find the probability that lost card being king. Okay. So probability that lost card being king given that randomly drawn card is king is equals to अब now denominator, probability that lost card is king multiply probability that card drawn is king. Okay, let me just tell you how to present it. Okay, first of all, E1 is the event lost card is a king, E2 lost card is not a king. Okay, then E is the event that drawn card is a king. Correct. Now, probability that your lost card is king given that card drawn is king. Remember, understanding is equals to now denominator obviously total probability. So denominator में probability that lost card is king multiply probability that drawn card is king given that lost card is king plus this is probability that lost card is not king and probability that drawn card is king given that lost card is not king. And now this thing will be written on the numerator. See, understand, let me tell you. Sorry, let me not tell you the whole process. See, they are asking probability that lost card being a king. Okay, so you have 52 cards. Okay, now lost one card is lost. So it can be a king. So now you have 51 card. Okay, now you have 51 card. 3 kings will be there because the one king you have lost, but 51 card you will be having if you are having card, lost card is not king. So this is not king. This is king. Lost card is king. Okay. So now you have to draw a card. Okay. So probability will be what? Probability will be what? So there are 2 ways lost card can be there are 2 ways drawn card will be a king. Understand, 2 ways that drawn card will be a king. What is one way? That one way is lost card was king. So if tell me 52 cards, lost card was king. What is the probability of lost card being a king? So ma'am, 4 by 52 multiply. Now the one king is gone. Now you want to draw another card. So you have 3 options, 3 by 51 plus. Now, again, this time lost card is not a king. That means lost card will be amongst the 48 not king cards, and now you have to draw a king. So 4 king intact are there. So 4 by 51. But what do you want? You want the probability that lost card being a king. That means this is what you want. So this is, I'm going to place it right here. This is 3 by 51. So first of all, this is how you have to do it. So 50 to 51, 50 to 51, this is gone, gone, gone. 4, 4, 4 gone. So this is 3 upon 48 plus 3 is 51. So 1 by 17 will be the answer. But how to write it? How to write it? You have to have a look. That, see, here lost card is a king. Here lost card is not a king. Here lost card is a king. Why here lost card is a king? Because the question is telling. Always in the denominator, write all possible solutions, all possible options, okay, in the denominator. In the numerator, only favorable probability is what you have to write. Now random variable, let me be very clear about random variable over here. That random variable mein understand that sometimes they do not give question, but in the sample year, 3 mark question was there. So that is why random variable I am going to teach. Okay. So random variable may understand very simple. Sometimes students make it very complicated. Random variable is just a person who is crack from his mind, and not even crack. The person who is like, who has no job, unemployed. Do you remember that unemployed Instagram people write everything in comment section, observe, observe. So random variable is that person who is unemployed, who will count anything which is random. Suppose I start counting stars. Okay. Suppose I start counting, okay, I can start counting number of A in random variable. So random variable is a person who is a counter, who can count anything. Okay. So for example, tossing a coin in 2 times in succession. So this is it. X denotes the number of heads obtained. So number of heads, here number of heads can be 2. Here number of heads can be 1, 1. Here number of heads can be 0. So now X, random variable, is counter. So it can be 0, it can be 1, and it can be 2. So this is what your random variable is. Okay. Now probability distribution table is very important. It's just that you have to understand this. Now every question will be done. So probability distribution table may you will have 2 rows. It can be horizontal, it can be vertical. So one is X, which is random variable, and another one is probability when your random variable is X. So suppose X is 0. So probability when your 2 heads are getting, probability that your 1 head is getting. So like that. We will do it. Okay. Do not worry about it. Let me just get you a table sort of thing. Okay. So let us just do a question. CBSE 2024. Can you see? Find the probability distribution of number of doublets in 3 throws of a pair of dice. So first of all, understand what is happening over here. 3 throws of a pair of dice. So we are throwing a pair of dice how many times? 3 times. Okay. So number of doublets. So suppose pair of dice, throw number 1, if I am throwing, it can be 1, 2. So how many doublets are you getting? 0 doublets. Then I throw it. 2, 1, 0 doublets. Then at 3, 1, 0 doublets. So overall, in 3 throws, how many doublets you are getting? 0 doublets. So this is X is random variable who will count number of doublets. So you have 2 dice, you are throwing it 3 times. Understand? Throw 1 can get you no doublets because both the numbers are different. Second throw also, third throw also. So X can be 0. Then X can X be 1? Yes, X definitely can be 1. If I am throwing a dice 3 times, So I'm throwing it, correct? And I'm getting 1, 1. Next I'm throwing 2, 1. Oh, hard luck. Next I'm throwing 1, 2, hard luck. So that is 1. Now 2 doublets. So I'm